Part 3 from 3 chapters. Impact from mechanical load during operation. Presented by Carbon Department, 2024. Industrial Standard for Pre-Baked Anodes. The properties of the anode are largely set during the baking process and must be carefully controlled to ensure an acceptable output efficiency and reduce the amount of undesirable byproduct produced. To that end, the aluminum smelting industry has settled on a range of acceptable values for commercial mass-produced anodes for the purpose of consistent, optimal performance. High attention on tensile strength. Weakness of our pre-baked anodes. Basically, our anodes have close to the standards. Only one parameter which is greater, namely tensile strength. Our anodes have tensile strength out of range, higher. This is because the green plant uses a vibrocompactor to mold green blocks, not a pressed compactor. High tensile strength often goes hand in hand with reduced flexibility, which means the material may lose its ability to deform plastically before failure. Due to our anodes have higher tensile strength, they have lost its elasticity and becomes more easily broken than anodes molded by a pressed compactor. Using FEM software yields a displacement analysis as the right image. Certain situation in carbon plant, related to broken anode. The clamp is not right in the middle of the anodes. If there is no anode next to it, it will go down. Due to its weight, moment force on each anode causes a downward tensile which can cause the weakest part to experience more severe cracks. This is an example of an extreme incident. One of anode loses the grip and one side of it slides down. The potential for crack has begun here. Certain situation in carbon plant, related to broken anode. Pallet is no longer flat. Imagine, if a pallet like this with a full load of 4 anodes, is placed on an ATC, old condition, then taken to the reduction plant. There's at least the influence of vibrations to the weakest part of the anode along the way, right? Certain situation in reduction plant, related to broken anode. Crushed bath material, alumina partially sintered. Hollow space. Molten electrolyte. Molten pad. Due to the dynamics of the process, material covered, the circled part, the anodes will be broken down. Flame will come out of this damage area. If it doesn't repaired as soon as possible, the pot condition itself is going to be worsen. The cover material alongside of the pot must be dismantled and then trimmed again. This activity is named dressing. Here, the chance that the anode will rupture. Even though the tip of chisel is not directed towards the anode but vibration transmits to the anode. Just see the dressing process. Certain situation in reduction plant, related to broken anode. TSR, thermal shock resistance, is a measure of the anode's resistance to thermal shock when installed in the pot. TSR equals 100% means the anode will be safe from cracking due to thermal shock. For example, TSR equals 100%, then the delta temperature between bath and anode equals 945 degrees Celsius. This means that if the anode temperature equals 30 degrees Celsius, then the bath temperature equals 975 degrees Celsius. If bath temperature greater than or equal to 945 degrees Celsius or anode temperature less than or equal to 30 degrees Celsius, then the anode will crack due to thermal shock. The greater delta temperature, then the greater potential for cracking. It's better to do preheating the anode before installing it. Certain situation in reduction plant, related to broken anode. From this simulation, to get TSR greater than or equal to 100%, it can be seen. 1. For large anodes, anode immersion equals 100 mm. 2. For medium anode, anode immersion equals 150 mm. 3. For small anodes, anode immersion equals 247.5 mm. From this simulation, it can also be seen that the smaller the anode, the higher the immersion will be to maintain the TSR at 100%. In other words, the smaller the anode changing cycle, the more wasteful the use of anode units. However, it can also be seen that an asymmetrical rod position, as in the picture, will result in the severity of broken anode being higher. Note: the larger anode dimension, the more asymmetrical rod position. It has the potential to cause broken anode. Okay, that's all I want to inform to you. Summary from Chapter 1 to 3. 1. Larger anode has higher risk to be broken. 2. In order to make larger anode, we should use hydraulic pressed compactor, not the existing one, vibro compactor. 3. There are a lot of situations either in carbon or reduction which contribute to broken anode incident. Quick win to overcome the rise of broken anode incident. 1. Replace LA4 with LA2. 2. Modify clamps anode tongue of our STC by making the clamp right in the middle of the anode body, in order to minimize spreading of crack, especially under, in between, hole number 1 and hole number 3. 3. Modify green block cooling system due to enlargement of anode, optimizing surfaces of block and conveying machine. 5 less than or equal to softening point of CTP reduced by 15 degrees Celsius.
End of part 3.